Okay, well,
Looks like it gave us different
you said what? What did you say?
numbers. Looks like, I said it looks like it gave us different figures. So,
Yes, yes, yes. I don't want to really dwell on this to avoid confusion for those among us who have not done arrow. Okay, but I just wanted to show that, of course, it's supposed to give different numbers. What I wanted to show you is
but
this.
you said it's the same thing. You can use it that way.
Yes, now, but here you can see you are saying mean of 50. Here, mean is 0, so it can't give you the same thing.
Okay, okay.
You cannot give the same range.
Then this same particular 10 main 20 main. I want you to do a random number of 10, 50, 10.
It will still be different. I explained this earlier, but like I said, since this is not an arrow class now, I don't want to cause confusion here. But it will be different. That's why they are random. If you do it again, it doesn't mean it will give you exactly like this. No, it will not. It will not give you the same
Okay,
thing, but it will be in the same range. Okay?
okay.
That's the point. You see these ones
Wow.
now, you have 30 something, 60
Oh,
something, 40
that is
something. Here, the same range. But here, you can see the range is different. This one is 0 point something, 1 point something. Are you following now? Okay. Now, the point
yeah.
I'm trying to illustrate here is that that's the way it happens with forecasting, where let's say, for example, you see this now, okay? These numbers that have been generated here, they are supposed to have a mean of 0, right? Okay, supposed to be a mean
Yes.
of 0. Okay, now look at something. If I say number, whatever, is assigned this, which means the numbers have been stored in this n now, right?
N.
I now
Yeah.
say
Yes, sir.
mean. If I get mean of n, it's supposed to give me 0, right? But you can see it's
Mm,
not 0, okay? But it's close.
to 0.
Yes, it's close to 0, but it's not 0. Let's do another one. So let's do mean again of n. You see 0 point something, 0 point something, but not 0. Okay, definitely.
That's what the forecast.
Then another thing is, see something interesting you should notice here as well. When the number is high, it's very high, like that's 10,000 now or 100,000. Okay, that's a very high number. If I do the mean, it will even be closer to 0. This is closer to 0 now than this one.
Yeah.
Because this one, the numbers were too few, just 10 numbers. This one generated 100,000 numbers. So the mean is closer to 0. This one is 0.00. This one is just 0.3. This one is closer. Okay. Yeah. So when you do, this is the same way that forecasting works. When you forecast, you may not get the exact thing, but if you do a proper forecasting work, you get close
Say
to,
something similar.
yeah.
Mhm.
And on the average, you will just be somewhere around the actual. Okay. Okay. So let's
What if your forecast is
if what I've explained here sounds abstract, well, let's just disregard that for now. Let's go back to our Excel. Okay.
sorry, what if
We'll
your
still do arrow afresh, so no problem with that for those of us that haven't done it. Okay. Charles, your question.
Okay, I think what is your forecasting is above the actual
It can
figure.
be above, it can be below, but it shouldn't be far from
Okay.
it.
Okay.
Shouldn't be far
Then I
from it.
guess Mr. Hartford was right. The first forecasting.
Yeah, shouldn't be far from it. But from what I did just now, you can see the law of large numbers. That when you can see why we talk about large samples all the time. Okay. When you do,
Yeah.
when you have large samples, you tend to get better results. Okay, so now how do we do forecasting? There are various models, various tools or models that we can use for forecasting. Regression is about the most popular. Regression analysis. You can use regression analysis for forecasting. You can use moving average. You can use weighted moving average. You can use exponential smoothing. Okay. So usually forecasting is not magic. Okay. So what you do is that you forecast, and then when the time comes, let's say you forecast income for next year. So by next year, after the actual figures are gotten, you compare the actual with your forecast to see how effective your forecast was. Okay. So you can use various methods for forecasting, and then the one that tend to give better results, then you can stick to that. Okay. So is the actual that actually tells you how well you have performed in your forecasting. Okay, so let's start with regression analysis. Let's begin with that. Okay. In Excel, regression analysis is quite simple in Excel. Now, what the concept of regression generally, what is regression about? What's regression about? Can somebody tell us what is regression? Or what is regression analysis used for?
Okay,
What
so
is regression
like
analysis?
to compare the relationship, this is a method used for estimating relationships between two variables something or more than.
Okay. Is that all? How does that differ from correlation?
I think correlation is just between two, to compare two variables.
Why regression is to compare what?
Relation is to compare relationship between one or more independent variables. I don't know if I'm making sense.
Well, it's good to attempt. Generally speaking, regression measures dependent relationship between variables.
Regression. What?
Regression is used to measure the dependence or dependency relationship between variables. Okay. So in other words, regression measures, it's used to investigate if or how a particular variable depends on another variable.
Another.
Yeah.
Where you draw their strength from, something like that.
Yes. What's the relationship or dependent relationship between one variable and another? Okay. It's used to measure the relationship between a variable and another. In other words, the relationship between an independent variable and a dependent variable. Okay. So the relationship is used to create, regression analysis is used to create a model which represents the relationship between one variable or one or more variable and another variable, which is called the dependent variable. Okay. Let's say, for example, look at this, for instance. Okay. Let's say we have advert expenses and sales. Okay. In most cases, we know that um, there's relationship between these two, right? So the more advert is done, the more sales we expect, isn't it? Is that right?
That's what's happening here.
Is that?
I said that is what the data is telling us.
Yes. Okay. So um, the more advert is done, the more sales we expect. Okay, that's a dependent relationship or causality relationship. So regression is used to do that. So regression can be used to create a model or an equation that connects these two variables, that defines the relationship between these variables. Okay, that's the first thing that regression analysis does. Also, it is used to compute the value of the independent variable, rather the dependent variable associated with a particular independent variable. For example, after creating the model that connects these two variables, you can then use that model to compute, let's say, for instance, advert expenses is 500,000. What will be the sales? Something like that. So you can use regression to do that. Am I communicating? Am I communicating?
Yes, you are.
Yeah. So the a simple way of doing regression in Excel is to just use the XY scatter, the scatter plot. Just do a scatter plot. You highlight the data, just insert your scatter plot. Sorry, let me copy this into that sheet. Wanted to plot the scatter plots.
Yeah.
You remember now. So you can just highlight your data, click on Insert. Then you come to, in the chart section here, just look for your scatter plots. Click on it. This scatter. Okay. So it gives you something like this. So this is the scatter plot for this data. Okay, for this data set. Then the next thing we need to do, what do you guys think what are we trying to do now? What are we doing?
We are looking for, I think, is it the regression values?
Yes, we are doing regression analysis. Okay.
Mm.
So I said we can do it. We can do that in Excel using the scatter plots. Okay. Now the scatter plot has been created. So this scatter plot you are seeing is giving us the relationship between sales and publicity expenses. Okay,
Yeah.
so we can add what we call chart elements. Let's click this plot here. If I choose axis axis data here now. So I can just call this, what do I call this thing? Publicity expenses or adverts, whatever. This publicity expenses. While this is what? This is sales. Okay. Now we need a trend line. We need a trend line here. To do that, you click the chart elements as plus. You come down to trend line, right? Then you can click this arrow here and choose the type of trend line you want. We want the linear, okay? Better still, you can just come to these more options here. So here you can choose the trend line option you want. I will explain all these other ones, what they're about. But for now, let's use linear. Then you go down. Okay. So down here, you display equation on chart. Click on display equation on chart, select that, and select display arrow squared value on chart. Select those two, okay? When you do that, it will give you these values you are seeing here. Okay, to give you these values. So it's telling you that this is the regression model or equation. Okay, don't forget that Y is sales, X is advert expenses. Okay, here to make it, you can just put X in bracket here so you don't forget. That's X. Y is sales. You can call that Y. Okay, call that Y. Let me expand it so you can see it clearly. All right, so this is our scatter plots. So what's this equation saying? This equation is saying that the relationship is as follows: y is equals 2.1451x plus that, okay? And then the arrow squared value is what indicates whether this relationship, this model is reliable or not. Okay, with an arrow square of 70 or above, that's okay. That tells you that this model is reliable.
Yeah.
Okay. If R squared is very low, like 1 point something or less than 3, it shows that the model is not good enough. It's not
Okay.
reliable. Okay. If it's between 3 and 7, then you can do a review, you can take a decision on that. But for you to reuse it, it's better you you do so when R square value is high, like 70 and above. Okay. Okay, so now what is this equation telling us? What is this telling us? What it's telling us is this. Let's say, for example, let's take a value of adverts. Assuming advert expenses, I mean publicity expenses. Assuming publicity expenses, somebody should choose a figure. Is equals
20,000.
20. 20 is small compared to
Say 20,000.
20,000.
20,000 is small.
20,000
It's small.
No.
is small compared to what kind of things we have here.
Okay, we can say like 250.
Okay, let's say 250. You could use the 20,000 anyway, whatever you want to use. But let's say 250. Assuming as you want to do 250. If advance expenses is 250, if you want to use 250 for advance expenses, what sales level, what sales, let's forecast sales based on that. So this equation is what you use to do that. Hope you guys understand what I'm doing.
Yeah.
Saying. So this equation is what you use to do that. We already know that y is equals 2.1451 x plus 842201. 842201. Okay. So what will be the sales? This X now is this 250, isn't it?
Yeah.
Because X is the adverts or publicity expenses. So what are we saying? Y will be equals what? Sales will be equals what?
1451
times 250
bracket open bracket times 250.
This, right?
250,000.
Yeah, plus
what?
842201.
Plus 84201. So this is the sales we are going to expect. This is the sales we are going to expect. It appears small, right? Appears small.
Probably
So it's more than that.
public expenses is too small.
There's something wrong somewhere.
Is the times going to be in brackets?
No.
The time going to be in brackets or what?
Wait. That's not the issue. this figure, I made a mistake here. It's supposed to be 2, 2.
Yeah.
Supposed to be 2. That's more like it, more realistic. How did I know that it's too small? How did I know? Because look at it.
It's lower than your.
Look at it. Just look at it. You see this 200 here is already giving 1 point something million, right? So if you were to project this line, extend this line, if you were to extend it,
Give you.
yeah, look at this 250. If we were to extend this line, it would have cut the thing through around here. Okay. So if you trace this to this side, you see it's somewhere close to around 1.4 million. You understand what I'm doing?
Yes.
Yes, sir.
So it couldn't have been that 600 and something that I got before. So when you are doing analysis, you must check things up. Just like you got that figure, don't just take it like that. You check if it's realistic. So by looking at that, I knew that there was something wrong, that the figure was too small. Anyway, so this is how you do. What are we doing now? This is forecasting. We are trying to forecast. So the